So the big idea with complex fractions and fractions in general is we really just should just think of it as times on top and divide on bottom. Okay? And if we have divide, divide, that really means times. If you have a times divide, that really just means divide. So if I take a look at this first example here, I have 2 divided by 5 divided by 5. Well, this means divide, this means divide. So really we can just express this in this way. Times 2 on top, divide by 5, divide by 5 again. Okay, so or, in other words, 2 over 25. So there's some easy ways to kind of deal with some of these things. And again, it's going to depend on where the fraction, the main fraction divide is. Okay, so again, times on top, divide on bottom is a good way to do this. Some people, will do this. They do 2 over 5 times the reciprocal of 5 and then get that answer that way. And that's perfectly fine. And multiplying by the reciprocal essentially is putting all the times and divide factors in the right spots anyways. But as it gets more complicated, we may want to simplify things even more to times on top, divide on bottom. So here we can have times x, divide by y, divide by 2. Okay, so we're going to divide by 2y. Okay, here, the a on top is times a. The 2 on bottom here is divide by 2. Okay, this 2 here is also divide by 2. It says divide by 2. And the c here is going to be divide and divide again. So it's divide by c. Well, that really means times by c. Okay, so we get AC over 4. Now again, you might want to just double check this because the multiplying by the reciprocal does put things in the right spots. Okay, so times by the reciprocal, yeah, that gives me the same thing. A times C over 4. Now, although this strategy is perfectly acceptable, we do need to be more fluent with this and more efficient with this. So if we're flipping and doing stuff with fractions all the time, it could be very difficult. So we should have some strategies here that should streamline things. So here I can use my times on top, divide on bottom. So I get times x, divide by a plus 3. I get divide by y, divide by a plus 3. And these cancel out. So I'm left with x over y. Now, you may want to start using a shortcut. Okay, there is a shortcut here. We can just cancel those factors out. Okay, because in the end, they are opposed to each other. That's a divide, that's a times. So we can, again, you could just use times on top, divide on bottom, but if you're fluent with this, you can start using some shortcuts here. Okay, what about this one here? Well, I'm looking at this and I can see right away, well, what I would do is I see times 2, divide 2. I would cancel those out. One thing we don't ever want to do is do anything with those, right? Because those are not factors. Okay, x is a factor. This x down here is not a factor, so we can't do anything with fractions on that. However, we can, again, I'm just going to use my times on top, divide on bottom strategy. So I have 2x on top and a on the bottom. That x minus 1 is divide, so that should be actually a times. And the 2 on the bottom is a divide by 2, so those cancel out. So I can simplify that to x times x minus 1 all over a. Here I can kind of see that these are going to cancel out. Okay, again, if we're not sure, we can kind of be a little bit more, use a few more steps with this. So I'm just going to again use my times and divide. So times on top, divide on bottom, divide by x. So that's time, and that means divide by a plus 3. Okay, that means divide by 2, divide by a minus 3. Okay, this is divide, so I'm going to do times x, times a plus 3, and those do cancel out. In fact, those x's also cancel out. Those are a little bit harder to see, but they do cancel out. So we end up with 2x plus 1 over 2 times a minus 3 on bottom. Okay, so if you know some shortcuts, and make sure that you're clear on these shortcuts, they work.